So much about this, and thank you, Babylon, and also BOB, as our portfolio, giving us the full support of this event. And now let's welcome our very next host of today. Actually, she's from Manta Network, Rui-Han. Welcome. And she's gonna introduce us to our next panels and keynotes of today. And good luck.
Thank you, Stephen, for the introduction. My name is Rui-Han. I'm from Manta Network, and it is our honor to collaborate with IOSG this time. And without further ado, let's dive into the panel discussion of data availability solutions and L2s by experts from the well-known projects. Let's welcome Oren, COO of StarkWare, Misha, founder of Nil Foundation, Austin, product manager of Offchain Labs, Marcin, chief protocol architect of Matter Labs, and Jeremy, co-founder and chief scientist of RiskZero. Also, let's welcome the moderator, Yiping, from the IOSG investment team.
Hello everyone, my name is Yiping, and really nice to meet you guys, and very happy to have all these leading projects in the DA and the layer 2 area today. Yeah, I think layer 2 is really important this year and popular. So yeah, layer 2 solutions have evolved significantly from their inception, each developing its unique features and capability. So I think although you guys are all leaders in the market, we can still start with some introduction here. Maybe can you guys provide an overview of your layer 2 solutions, your product, emphasizing its core value and vision?
Yeah, sure. So I'm Jeremy from RiskZero, and we're primarily focused on making zero-knowledge proofs easier and more accessible to a much larger variety of developers. And we're actually being used by some layer 2 solutions, although we are not ourselves a layer 2. Effectively, our main technology allows you to write arbitrary Rust code and then have that run inside a zero-knowledge proof, which has a ton of useful impacts across all kinds of different infrastructure projects. So we're sort of like a infrastructure project for infrastructure projects.
Okay, let's go for it. Then Misha, I bring coffee at nil. So what does that mean? What are we doing, right? It's like we have recently went out with what we call the ZK sharding thing. So what's that? It's effectively an attempt to horizontally scale ETH, kind of bringing sharding to ETH without the necessity to upgrade ETH itself. That's the thing. It kind of can be called an L2 solution, of course, as well. Yes. I mean, the point of this thing, I mean, we're trying to save ETH from being balkanized. We're trying to keep it horizontally scalable. We're trying to keep liquidity on ETH. We're trying to, effectively, yeah, I mean, we're trying to prevent it from being fragmented. That's the thing.
Hey folks, I'm Marcin. I'm Chief Protocol Architect from Matter Labs. We're doing ZK Sync. ZK Sync is currently the cheapest L2 rollup, and with actually lots of traffic, lots of TPS. We currently hold the record for number of sustained TPS. So our mission is, on one side, ZK is the end game when it comes to scaling Ethereum. It's just the matter, actually the fact that I think 4 of us out of 5 are actually doing zero knowledge. And Matter Labs here, we've been doing it. Our system is quite mature. We've been already in mainnet for more than a year. So if you want to have Ethereum security and cheap fees, come and use ZK Sync.
Hey everybody, I'm Austin Marrazza. I'm a product manager at Offchain Labs, the creators of Arbitrum. We are the leading scaling solution for Ethereum. And our latest product, Arbitrum Orbit, allows anyone to permissionlessly launch their dedicated chain using Arbitrum tech. Arbitrum technology and our rollup scaling solutions are the most mature and decentralized stack that exists out there right now, and with some various customizations you can make. We can cater to your use cases for your chain.
Hi, I'm Oren from StarkWare. What we're currently doing is we're mainly building large parts of the infrastructure of StarkNet, which is general purpose validity rollup. Sometimes it's called ZK rollup. I think validity rollup is a better term. Before that, we were probably the first ones who actually put any validity rollup on Ethereum mainnet. That was already 4 years ago with StarkX. But now we're mainly focused on StarkNet.
Yeah, it's a great introduction. And I think we can dive deeper into our topic, data availability. I know you guys all have some experience working with data availability. And choosing the right data availability is a critical decision for any layer 2 solution and maybe for app chains. Can you explain the factor and consideration that guided your decision-making process when selecting the data availability layer?
Sure. So, internally, we don't have a specific data availability layer because we're not really in L2. That said, I do think that there's an interesting overlap between zero-knowledge proofs and data availability in that the latest sort of data availability technologies, such as data availability sampling, effectively end up being a mechanism by which you prove that a portion of the data is a correct portion of a whole piece of the data. And in fact, actually, interestingly, there's been some new and emerging research about using things like Stark-based proof systems, well, not Starks themselves, but like the Fry component thereof, as a mechanism for doing data availability. So I think there's definitely a lot of really good products out there. We are looking at doing integrations with both Celestia and are sort of having some early discussions with EigenDA. I think that we will see continued sort of improvement in terms of these technologies moving forward. I mean, I think that fundamentally these sort of represent, along with EIP 4844, which of course also has sort of similar underlying coding technologies, I think are all going to be really helpful because obviously data availability, especially with regard to when an L2 puts things onto the L1, are in fact a major bottleneck in terms of L2 performance.
Well, regarding DA for ZK sharding, there are nuances, let's say it this way, because it's like being a high-performant thing. It's hard to put all the data on ETH, let's be honest. I mean, because if we start putting all of our data, ETH will get immediately congested. That's not gonna end well, all right? So on our side, no matter we have considerations on how to try to achieve this, we still maintain an optionality for the DA choice for each shard. So, I mean, effectively, if fellas wanted to use whatever INDA or like Celestia or something, feel free, sure, if that works for you. It's like up to the shard hosts. That's the thing.
So for now, we have to use Ethereum because other DAs are not ready yet. We can talk about Celestia and people use Celestia, but there's a second question about, can you actually verify on L1 that this data is there? Can you? I tried. It's not that easy. So basically, right now, Ethereum is the only DA that can actually offer this level of security. At the same time, being the zero knowledge means that DA is not as crucial as for optimistic rollups, right? Because here, I mean, it's still important, but it's not that important. So one thing.
The thing is that
I said bad things about Celestia and it's gone. Oh, shit. So the TLDR is like, yes, when more DAs will be available, we'll also have choices for our customers to pick different ones, but for now, Ethereum is the only possibility.
Yeah, no problem. It's a good question. So there's over 50 Orbit chains in development right now, and many of them have chosen to use alternative DA layers other than Ethereum. Offchain Labs' in-house solution, AnyTrust, utilizes an off-chain data availability committee that's actually been in production on mainnet for over a year using Arbitrum Nova. And so when it comes to any trust, when it comes to Celestia, when it comes to EigenDA, I think it really just comes down to what security and cost trade-offs that you need to see. Arbitrum AnyTrust is the cheapest and the simplest because you're simply just using off-chain servers. These servers will come to consensus on that availability and post a certificate of their commitment to making that data available on L1. But the data is being stored off-chain. With Celestia, even though it's not on Ethereum, you're still posting that data onto a blockchain, and some guarantees come along with that. But anyways, those guarantees are not nearly as strong as posting data to Ethereum. So there's this almost spectrum between security and cost. Celestia, you get to plug into a distributed set of nodes. EigenDA has a lot of economic stake at risk for the AVS operators. And Arbitrum AnyTrust relies on a whitelisted set, and this set can be elected and dismissed by a governing DAO. And so it's really up to the chain. I think we're seeing that most of them, if they're not aiming to have significant value on their chain, opting for AnyTrust because it's the simplest and cheapest. And while it's may not be the most decentralized, you still get to reap a lot of the composability and interoperability benefits of a blockchain.
So I agree with pretty much all that Austin said here. The basic trade-off is indeed between cost and security. And of course, from the security perspective, posting data on Ethereum on layer 1 is the best, but it's also very costly. By the way, we saw that with StarkX. StarkX was our application-specific rollups, sort of app chains before the term even existed, where we had both options. So whoever chose to run an app chain could choose whether they wanted to post the data on chain or in some data availability committee, the same way that Austin said, like just 4 years ago. Most actually opted for the latter. But not all of them. Some actually did post the data to Ethereum. When we started with StarkNet, which is a general purpose network, it was very important for us to enable security from day one. So for instance, it was very important for us that when we deployed the network 3 years ago, it already had ZK proofs. It basically had proofs proving the blocks. It had a lot of missing feature, but it had proofs because we don't want to compromise on security, so we also started with on-chain data availability on Ethereum. And up until this day, this is what StarkNet offers. Now we're going to see what happens with the cost with 4844. It'll probably bring it down, but I'm still pretty sure that for a lot of use cases, that won't be enough, and there would be different applications and definitely different app chains as well who would want to take the other side of a trade-off. We're willing to trade some security for lower cost. So longer term, what we're planning to do is something called Volition, which basically said we want the network to support multiple data availability offerings. And basically, the developers who are building the contracts could decide they could code within their contract which data availability solution or solutions are basically supported by that contract. In some cases, they may even let the user choose. So for instance, think of something like ERC20s. Maybe there could be accounts. The user could choose to keep their account either on high security data availability, which will cost more for transactions, but will be more secure. And maybe they're going to keep a small fund that they're going to keep on using like a hot wallet on a lower security data availability solution with a higher risk. So both will be supported.
Thanks for sharing thoughts about all the data availability stuff. And yeah, when looking at various data availability solutions in the market, I know they are still in the early time, immature, but do you think, are there any specific features or capabilities you wish were available to enhance your products?
Yeah, I mean, I think one of the core things to look at, of course, is the way in which the data availability layer scales. There was a lot of discussion about that at the earlier thing today. I think that another important thing is sort of how the data availability layer can be verified within, for example, an L1. For example, Celestia is working on effectively a mechanism to bridge the proofs of each block onto the Ethereum L1. But I think those are sort of the major factors. And of course, there's lots of, like, as I was mentioned, sort of security versus cost trade-offs. I mean, clearly, one could do a more private DA kind of solution. I actually think the sort of independence of data availability and sort of the compute will become a more sort of common direction that some of these systems are going to go, sort of this ability to pick your own DA, as was discussed earlier, which I think, because of the sort of effects of zero-knowledge proofs allowing you to prove the correct execution sort of independently, you're sort of seeing this ability to split sort of the execution, the data availability, and the consensus mechanisms into finer sort of decision logic. So,
You know what's the primary disadvantage of all the DA available on the market? It's like they all separate L1s and they all lack of proper security. I mean, like, what the hell is Celestia's security in comparison to 100 bill of ETH security? Nothing. Come on. It's like, and if you use that for storing the data, you're reducing effectively the security of the whole system to, that DA layer thing. Because if you don't have DA, your data is lost. So it's like, that's what's missing, and that's what nobody knows yet how to achieve. So let's say it this way. I mean,
So I would say that for ZK, DA is like insurance, right? You're gonna need this. In theory, never. Hopefully never, because your chain will be okay. People can just query your chain. And only if something goes wrong, if your operator becomes malicious, then everybody's running to the DA. And the main problem with insurance is you kind of hope that it will work when it's needed. And that's my biggest worry is I would like to make sure that DAs actually test these worst case scenarios. That they don't hide between, trust me, bro, it's gonna be okay. Like, when the thing comes, you can come and pick up the data, but they actually drill this. That when networks are under trouble, when Ethereum or L2s are under trouble, under attack, DA is really there. And that's what I'm missing, because we're talking all about features of DA, but comparing it to the insurance, if you're buying your health insurance, like, the fact that your hospital is proud of, like, hey, look at the new parking garage we bought. You're like, okay, fantastic, but I want to know about your doctors. Same thing here. I want to make sure that these DA layers spend enough time testing the security and availability under critical conditions before we talk about the features that they will introduce.
I generally agree with the spirit of this conversation, but I think just to take maybe the other side of this argument, at least for the demand we're seeing for many of these chains and app chains, is there's a lot of them are just on-chain video games, where like the stakes aren't that high, and in the case for roll-ups that are securing significant value and people are putting significant amounts of their life savings on your chain, and in that case, like this is extremely important. But for some of these chains that we see are spinning up and really just want something on chain and not necessarily like extremely hardened security and decentralization, there, alt DA unlocks use cases that were not practical before without, when posting data to Ethereum. And so while we're very far away from like this security and decentralized roadmap for many of these alt DA solutions, they do offer these teams to build something now and today. And it's important that we stay on it and can progress along that roadmap. And maybe just to answer like the original question of what features I would like to see. there's something we're working on right now. Optimistic rollups have a 7-day withdrawal period, and one thing that's nice about AnyTrust is that since you're already relying on this data availability committee to store data, to make data available, you can extend the responsibilities of that committee to also attest to the validity of the chain state transitions. And if you do this, you can actually bypass the challenge period and enable withdrawals in the same amount of time it takes to get L1 finality, so 15 minutes. And I know some people on this panel, based on previous responses, are going to hate this. But for some of these use cases that I'm talking about, where the stakes are not high, I want to be very clear about this. It offers extremely good UX. Like, we can talk all day about how to build the most hardened protocols out there, but to really onboard millions and billions of users, there's going to be an entire spectrum of use cases, and some of those use cases do not require the highest level of security, although we should, of course, be making progress towards that.
So why do you need DA at all? If you don't care about the security, why do you need DA at all?
Well, security is a spectrum.
Sure, but you can just use SQL, it'd be done.
Right, but security is, again, a spectrum. And so what AnyTrust gives you is a whitelisted set. You could have one committee member, and that's essentially just a server, and you never have to post DA certificates to L1. But this is why we have a committee with, reputable entities from multiple parties that come to consensus on availability. And if we're talking about security, if multiple of these committee members go offline and that certificate can't get posted to L1, AnyTrust will actually fall back to being a rollup and post its data to L1 Ethereum. And so the liveness of AnyTrust is actually much, much better than a sidechain.
So in terms of features, low cost, good security, but I'd rather be rich and happy and healthy than the opposite. But naturally there is a trade-off here. But these are definitely features that you need to look up. So for each data availability solution, what's the actual cost? What security does it actually offer? I think it was mentioned before, it is important, especially for validity rollups, that it could be verified that the data is indeed the data that accompanies the state changes. So it should be, we should be able to prove that the data that was published was indeed the data that we're referring to. That's very important. And I agree there is a spectrum, and there will be a variety of use cases that will take different trade-offs. So they'll choose different things along the spectrum.
Yeah, really amazing discussion here. You guys really illustrate the spectrum, the trade-off between the security, the cost, and the user experience. I think we will jump to the layer 2 topic here. With the emergence of high-performance EVM-compatible chains and layer 2 solutions aiming for 10,000 transactions per second, how was this influence your product development and strategy over the time?
Yeah, I'm not sure I have anything particularly relevant to say on this particular one. I just want to make one final statement, though, on the earlier data availability discussion. But specifically with regard to the notion of, as you sort of see this notion of data availability systems which are held down by staking mechanisms, or where data availability is sampling across these things, I think that there is definitely a place for, I'm going to play some online game with my buddies, and as long as there's 1 million of value at stake, good enough for me, right? And I do think that it's going to be a weird world, because in some ways one of the important things is, if there is different levels of economic security for the different parts of your L2 or for different applications, there's a major UX problem of making the sort of end user aware of what they're getting. in terms of economic security. And I also think there's a little concern, in my mind at least, that end users may not make wise choices about their level of economic security, and then may end up blaming the protocols anyway for the decisions they made. But I do think that to not consider these different levels of security is probably, I think there's room for it at some point. That was my quick version.
It's like when you mentioned when you mentioned certain performance levels, like in the question, it's like fine fella to the left hand of me kind of lost pretty openly about this. So it's like we are one of those people who try to do high performance, who try to make it high performance. It's like while kind of making it and kind of keeping it composable. It's like yes, there are bottlenecks. I mean, of course, it's like I kind of know even what the bottleneck is about, and I know what the lath is about. So the bottleneck is about like essentially proving the whole thing. It's like because that's the security, because that's what causes the security delay effectively. It's like when I mentioned certain performance level, like we went with whatever, like 60K transfers per sec. That what we went with. And effectively, when we're talking about transfers, we're talking about just ERC20 transfers or something like this. Pretty particular set of opcodes to prove, to be honest. And it's like the bottleneck about this. We're kind of working on this. It's like recently, runtime verification folks have done their benchmarks of proving this kind of bytecode. It's like compiled by zk-LLVM. And I mean, since we compile the EVM with the same compiler, so it kind of applies. I mean, we're targeting to compile it this way, right? So that's this way. So it kind of applies. And it's like they did quite a comparative benchmarks. I mean, it's like guys to the right hand of mine are also present in there. It's like, in case anyone's interested, it's like the difference in performance between like, an average ZK VM and like, manually built circuits or compiled circuits right now is about like 20-25 times just to prove the bytecode, which does the ERC transfer. So the bottleneck is not that bad. In fact, it's like the DA is also, might be the bottleneck, but we're working on, making it available all on ETH. Tricky. There will be nuances, but anyway, if it's not possible, we will, opt out to different DA. But in general, I mean, horizontal scalability gets this performance. It's like, don't laugh at it.
I'm not laughing, I'm supporting it. Okay. I'm actually waiting for the moment when we're not only going to build systems that do 10,000 TPS, but they actually have enough actual users, actual real use cases that use
it's about the design space. It's all about the design space. If you just do the plain EVM, of course, you'll not have a new design space. So it's all about, extending what's possible.
Exactly. And as a part of this, yes, in order to achieve this, we will have to go in some types of sharding, whether it's going to be identical sharding or whether it's going to be more like fractal scaling with L3s, allowing a little bit more modifications and like separate chains. That's a separate thing. But one thing that will be important about this is we will have to shift to more asynchronous computations. And this will be like a big shock for many developers.
I think one thing I just wanted to mention in terms of the sort of higher scale EVM models is the EVM model has this notion that you can compose an arbitrarily large number of things that touch an arbitrary set of the state in a single atomic sort of transaction. And I think that that's, at this point, if you look at scaling, DA is in some ways more expensive than execution, and the execution scaling with things like ZKPs can be made much larger. But as you start getting to these higher and higher levels of scaling, you're going to run into these issues, which is that the transactions don't decompose and parallelize properly. And I think that's partially the model in which the EVM was built. And so I think you will start to see potentially the emergence of either modifications to the EVM model to do sort of more asynchronous type of behaviors, or new models arising in terms of that are still general purpose computing models, whether actor model, or there's a number of other things people are experimenting with. But I think, it's going to take a different viewpoint because people do make use of that composability for a lot of use cases, and so it's going to be a hard thing for people to let go of, I think.
Yeah, I could talk a little bit about a solution we've been thinking about at Offchain Labs called chain clusters. The premise of this is similar to horizontal scaling and fractal L3s, but the gist of it is that one shared bridge contract between many chains and a shared validator set between many chains. And when these chains can share a validator set, it essentially means that they can trust each other. And if they can trust each other, then there's a path towards a native cross-chain interop solution where you can bridge assets and arbitrary messages between chains in under a few seconds at the time of the pre-confirmations. This is great. There's a trade-off here, an important one, in that it's a weakest link phenomena. And so if one chain in the cluster goes down, they're all going down. However, this trade-off can be acceptable if it's one entity running all of these same chains and they're not explicitly trusting a bunch of other organizations to maintain their other chains. There's another path here for chains that are running with similar code bases, and you wouldn't want to have like rollups posting data to Ethereum in a cluster with a chain posting data to an off-chain data availability committee. But this is exciting because for these teams that really have a vision to scale beyond one chain, if say they really want to have an ecosystem of games and each game has its own chain, this makes it possible for them with technology that's available today. And so even if one chain maxes out at say 100 TPS, you could theoretically have a cluster with 100 chains inside of it that can all interop with each other in a couple of seconds. And so this is a huge unlock. Even, there's a lot of exciting work being done with native interop, with ZK proofs and other implementations and liquidity bridges. But many of these, the latency can still take several minutes. And so taking this down from several minutes to several seconds is a huge UX unlock that I'm excited about.
So scale, or rather throughput, I think is extremely important for rollups. It's actually, I think, the main reason why you need rollups to begin with. Otherwise, you could just stay on the main chain, everything's fine. Well, there are other things such as privacy, but that's the main thing. So it is the main thing we're thinking about and have been thinking about since day one. I'm putting aside for a second the horizontal scaling and layer 3s. That will definitely give a significant boost in terms of throughput, but I think we're still very far from the limits of what a single chain can do, or let's say the main rollup chain will do. Like the public StarkNet could do a lot more than it could do today. Now there are basically two parts in validity rollups in layer 2. So you have the sequencing that generates the blocks, and then you have the proving that generates the proofs that attest to the validity of these blocks. And unlike what many people think, the bottleneck is actually not in the proving, it's in the sequencing, because the proving is highly parallelizable. So if we could generate blocks in a very, very high rate, we could spin up lots of provers and prove lots of them in parallel. Even today, it's not the bottleneck. It has a significant cost perspective, but it's not what's limiting the throughput of the chain. What is limiting is actually the sequencing. And here, the main problem is that there is a sequential element to sequencing, and it's the same in Ethereum, it's the same in layer 2s. There's a lot that we could do in parallelization, but then it depends on the interdependencies between the transactions. So it's a statistical thing, and I think we could go a long way, but it will have its limits, and after that, we may need to think about things that are more radical. But I think we're far away from that. So if you look at StarkNet, throughput of the network today is like a couple of orders of magnitudes higher than it was a year ago, and it's probably going to be 1 or 2 orders of magnitude higher like a year from now. There are lots of things where we're like a large part of our roadmap is actually that, in improving the throughput of the sequencer, through parallelization, and even initially, the main reason why we opted for a non-EVM virtual machine, so we have a Cairo VM, the main reason for that was that we didn't want to carry the limitations of EVM to the validity rollup space, because there's no need to, both from the functional level, but mainly from the scale perspective. So longer term, we believe that this is going to end up with a much higher throughput, but time will tell. The burden of proof is on us.
I kind of do not agree that the main bottleneck is sequencer. I mean, it's like it is, all right, it is, but it is getting solved in case you parallelize effectively execution and remove data access logs. That's the first thing. And the second thing regarding the proving being or not being a major bottleneck, I mean, it's like, you remember Cairo native project? It's like which kind of was built to be able to put down Cairo to, I mean, MLIR and then LLVMIR. It's like, yes, it was done initially, like, you know, in, as far as I understand, I mean, Oren, like, correct me if I'm wrong, StarkWare was interested in this for the sake of putting this into the sequencer to make sequencer as fast as possible.
We still are.
That's like the initial idea, but besides that, it's like, just in case, it's like today Lambda class folks have lowered down effectively Cairo through Cairo native to LLVMIR, which made us possible to prove LLVMIR, which was, you know, produced by Cairo frontend, and it's like immediately several projects built on top of StarkNet were like, oh, I mean, let's try it out. Maybe we'll get a better proving performance. It's like, and this is before we're going down for hardware acceleration. I'm not even talking about that. So there is a bottleneck in proving, let's be honest. It's like, so it's there.
Well, I think there's a difference between like a bottleneck in terms of maximal transaction rate versus a bottleneck in terms of cost. I mean, clearly the proving is much more expensive than effectively the sort of sequencing or the determining of the next state of the system. But it is able to be split up as widely as you would like, and so it doesn't really affect the maximal transaction rate, just makes all the transactions more expensive. Of course, if you make proving faster, which there's a lot of good work, you know, a lot of people are making major performance strides in terms of proving. We have a lot of work on our, you know, I think we're going to like a 10x over the next 6 months on our current performance roadmap. I think that's going to come down, and actually for a lot of cases right now, actually DA is the more expensive if you want it on like an L1 DA than the proving for a typical transaction, right? Although that said, I think your earlier statement that you made with regard to, well, even if we had 10,000 transactions per second, would there be anyone, you know, sending those transactions? And I think so. I do think that some of these concerns about the sequencer causing bottlenecking are still, you know, there's still quite a bit of room for improvement over where we are before we start hitting that. And I think that, you know, we obviously need to make sure there's enough transactions for it to be worth doing. So.
Yeah, it's a really good discussion. I hope everyone in the room gets some inspiration from us. And thanks again for everyone here. Thanks for your time. Really nice to meet you.
Thank you.